Hello, these two problems we're going to do without a calculator. So let's start with the first one. What is the total mass of products formed when 16 grams of CH4 is burned with excess O2? So the first thing we need to do is get a balanced equation. So it has CH4, and it says burn. So that means we're going to add oxygen. Oxygen needs for something to burn. And I can see this is a combustion reaction, so I'm going to need to make CO2 plus H2O. I got to balance the equation first. I got one C on both sides. That's good. I got four H's here. I need a 2 here. That makes 2 O's. 2 more O's make 4 O's, so I'll need a 2 out front. Okay, so I got a balanced equation now. I want to figure out my total mass of products. So I'm going to ask myself, well, how many grams of CO2 do I have? And how many grams of H2O do I have when I happen to burn 16 grams of CH4? Okay. Now, these kind of problems you're going to be doing in multiple choice answers, so we just kind of need whole numbers. Now, these don't have those kind of answers, but we're kind of going to get a set answer for that. So the first thing I need to do is change grams into moles. And when I look at the periodic table, carbon is worth 12, and hydrogen, well, is 12.01, but we're going to call it 12, and hydrogen is worth 4. Not exactly 4, but pretty close to 4 when you look at the periodic table. So 12 plus 4 makes 16. Put that on the bottom. Do you see how they work out kind of nicely like that? Usually these kind of mental math problems will work out that way. Now I'm in moles of CH4, so I got to put moles of CH4 on the bottom. There's 1 mole of CH4. And that's for every, now going to moles of water, I see I have 2 moles of water. 2 moles of water. And on the top part I need moles of CO2. So for moles of CO2, I kind of put that in a weird order. 1 mole of CO2. That just looks weird, sorry. There we go. Now we got to get out of moles and into grams for its respective products. So here on the bottom I'm looking at H2O. So 1 mole of H2O is how many grams? Well, each H is about 1 and O is about 16. So 16 plus 2 more makes 18. Technically it's 18.0148, but you always want to round it off in some way. CO2, we're looking at carbon has 12. We've got 2 oxygens, that's 32 each, 32 total, 16 each of them. So that's 4, 4, 44, 44-ish grams of CO2. It's not exact, we don't want to do exact. Okay, now I want to try to simplify these problems a little bit. So I've got 16 on top, 16 on bottom. That simplifies it. I got a 1 to 1, and all I have left, oops, there's a 1, is 44. So there's 44 grams of CO2. This part, I got my 16 on top, 16 on bottom. I've got 2 and 18. Now I just got to think about what's 2 times 18. Come on, brain. 36. 36 grams. Now the problem asks, what's the total mass of the product? So here I want to add up the 2. 44 plus 36. So 0, 1. We're looking at 80. About 80 grams of products. Okay, let's go to our second one. The reaction of 7.8 grams of benzene with excess, that's handy, I don't have a limiting reactant problem, results in 0.9 grams of H2O. What is the percent yield? Okay, so I gotta ask myself, well, question mark grams of H2O, how much water did I predict I would make? Theoretically, how much water should I have made? I made 0.9 grams, actually, but I want to know theoretically how many grams of water did I make from 7.8 grams of benzene, C6H6. Okay, so I got to get out of grams and into moles, C6H6. All right, this is a little trickier. So I'm thinking to myself, I got, each carbon is worth 12, and there are 6 of them. 2, 1, 6, 7, 72-ish. I got to do side math. 72 plus 6 more is 8, 78. So I'm looking at 78 grams. Oh, handy. That's lovely. If it doesn't work out when you get that number and you're like, oh, that didn't work out kind of nicely, it's not to say it won't kind of down the line, but it's kind of a sign that this isn't going so well. You might need to relook at your math. Now I got to get out of moles of C6H6 and into moles of H2O. It happens to be a 1-to-1 ratio. Yes, that's a balanced equation. Okay, had to double check. And then I want to get out of moles of H2O and into grams. And that's about 18. We did that math up here. Okay, so taking a look at that, I got 7.8 divided by 78 times 18. Now this is where you have like those parts of decimal places, and that makes things a little bit tricky. So 7.8 divided by 78. What could I do there? Times it by 10. So the way I kind of think of it, if I times it by 10 here, whoop, I get 780. I times it by 10 on the bottom. 78 and 780. When I have the decimal place, I just get all funky with that. But what I did is I multiplied the top number by 10 and the bottom number by 10. So really all I did was multiply it by 1. And now in my brain, I can think about it easier. Okay, 78 divided by 780. I know that that's a factor of like 100 difference, so I know that this is 0.1. This is the kind of math where you might need to be like doing some more practice with, because this kind of which way do I move the decimal sort of thing is hard. I know it's going to be a 1 factor. I just don't know where the point is going to be. In my brain, 100, this is 100, and so I'm going to move it boop, boop. I don't know. That's how I work in my brain. So now I've got this whole thing is worth 0.1. This is 1 times 1 times the 18. This is me simplifying it. So this is worth 0.1 times 18. I got 1.8. Okay, because the 0.1 moves the decimal place 1 to the left. So I've got 1.8 here. Now I'm finding percent yield. Percent yield is actual, which is this 0.9, divided by its theoretical 1.8. It works out kind of nicely. And then we're going to multiply it by 100. So you can see right there, I'm going to have a factor of 1 over 2, right? Now here's the tough part. So I'm going to move both things, multiply both things by 10. So I'm going to move it over. This, in my brain, is becoming 9 over 18. That's 1/2. So that equals 1/2 times 100. 0.5 times 100 is 50%. I'm going to do my calculator on the side here just to be sure. Divided by 1.8. Yeah, I did a good job. Okay, perfect. So 50% yield. When you do things, a hint that you can do with things is to kind of simplify things down. Like if, let's say this was a 2 right here, then you would want to go 2/18. You want to simplify that down to like a 9er, you know? Or, I mean, anything that's happening, any way you can simplify these fractions down is where you want to head. And hopefully that'll make it easier for you. I would suggest looking at these tens part if that also trips you up, because it trips me up. That's where AP likes to do the most work, is in that sort of thing. All right. Oh, this is not what I want. What is my screen doing?